For the dog and the hair problem, I'm just going to sort of sketch this out and set it up for you so that you can get started on it. What we have is a situation where the person is walking their dog and they're walking in this direction along the x-axis, and the length of the leash between the dog and the person is, I believe, 2 meters. Okay. So with that given information, everything's fine as they're walking along that axis until the dog spots the hare or the rabbit, who is now traveling sort of north up along the y-axis. And we're not given any velocities or anything like that, but we'd actually just don't need them, okay? So what's going to happen is probably you're picturing already the sort of a right angle triangle effect, because if the leash is pulled tight, it's always going to be sort of that, like, like a diagonal line between the person and the dog. And I draw a dog and a person for you, but my diagrams are laughable, so we don't want to do that. All right, so what's going to happen is we are going to get a path for the person. I think his name is Max or something, because he's going to get pulled off of his x-axis as this crazy dog chases the hare up the y-axis. And the path of the person as he's doing that is going to be along this arc, even though we know that the leash is pulled taut, and it's going to be, always that diagonal straight line between the dog and the person. So here's how we deal with setting this one up. Let's start with a new set of axes. And what we're going to have is, at any point along the line, we are going to end up with a Pythagorean relationship, a right angle triangle. Here's our leash, which is 2 meters, and here's our person right here. We'll put an M for Max, shall we? And he's at some point, X and Y, on our grid, and we don't really know any more than that. And on the y-axis, we can't call this distance y because it's not starting at the origin, and in order for us to call it y units up, we would have to start at the origin to do that. So let's call it something different. Let's call it maybe side A for that triangle. And we can call this side x because it does start at the origin. It starts at 0 on the y-axis and goes out. So you remember your Pythagorean theorem. If you don't, I will remind you. It's a squared plus b squared equals c squared. And that's when you have two short sides, a and b, and a longer side, c, the hypotenuse for a right angle triangle. So what you're going to do here is you're going to set up the Pythagorean relationship for the things that you have on this triangle, and you're going to use this formula, and instead of a, b, and c, we're going to use x and a and 2 meters. And I want you to solve that equation for a when you're done, okay? So you'll end up with a equals the square root of something. Don't want to do all your work for you here. And we can toss out the negative square root because it doesn't make sense. If we're trying to find a is a length, then a negative would not give us a length. That wouldn't be possible. So we're going to keep the positive square root only, okay? So now what we're going to do is bring some calculus into the mix. We're going to look at this a little bit differently. We're going to look at this line, and we're going to say, hey, that line has a slope, and it's also a negative slope because it's going downhill. And we know now from calculus that whenever we talk about a slope, we call it m in high school. Now we call it dy dx, right? It's the rate of change of y with respect to the x, or the difference in y, or the difference in x, if you remember doing first differences in high school. Another way to look at that is y2 minus y1 over x2 minus x1, right? And so when you are looking at that relationship in terms of the slope of our hypotenuse of our right angle triangle, then we can also find a difference in, we can find a formula in terms of what we're given in terms of dy would be negative a, right? And dx will be just x between 0 and x, okay? So if you take what we have done so far now and you put those two things together, then we do have an expression for a from here that we could now substitute in here. Leave the x alone, and you'll now have a formula that just has dy dx defined in terms of all x's here. So you're going to substitute what you got here into your formula for a and make it negative, and then you've got dy dx. All right. So that's the easy part. The second part of this question is actually asking you to come up with a function, and it's referred to as y equals f of x, I think, in the instructions for you. So they're asking you to come up with a function y equals f of x that describes the path of the, how do they put it? I can't remember how they put the question, actually. What we need to do in order to get y, if we know dy, which remember is y prime, is to use a process called taking the antiderivative or integrating the derivative in order to get back to the original function. Now, from what I understand, you haven't really done a whole lot of that in your class, so I don't know that you're expected to do this by hand. According to the assignment, it looks like you are now to go to Maple and tell it what you know about the derivative of this function and ask it to integrate. And don't forget also that we do have the point on the curve at some point, which will be 0, 2, right? And so using that information and using Maple, you should be able to find the equation that you're required to find here. And so I'm going to leave it up to you to do that, and you may find some extra help on that also in the Math Help Center, room 338 in Zosky College, where there are also computers with Maple on them.